everyone. I'm Peter van Huisden from the South African National Bioinformatics Institute. And while these days I work as a bioinformatician, my background was originally as the lab systems administrator. So I'm very happy to invite our keynote speaker, one from the same guild of professions, Radoslaw Poplawski, who is a systems administrator at the Advanced Research Computing Facility at the University of Birmingham, and maybe more relevant for this particular talk, one of the main architects behind the UK Medical Research Council's CLIME, or Cloud Infrastructure for Microbial Bioinformatics. So I welcome you to the stage and hope everybody.
Thank you. So I'm Radoslaw. I'm going to give you an overview of COG UK infrastructure we set up for this pandemic. So you may heard we recently processed 500,000 samples, and I give you like a bit more details how this all runs under the hood. So first, everything runs on CLIME. For those who don't know, CLIME is MRC-funded project. Basically, it's a cloud infrastructure for microbial bioinformatics. It provides free compute for any UK-based researcher working on microbial bioinformatics. There are currently 4 sites providing the compute, which is Birmingham, Warwick, Swansea, and Cardiff. And this project been active since 2014. I've been with CLIME since 2016. Basically, the day it went live, it was the 2 years preparation payment. What is COG? So COG is consortium of, it was set up in March 2020 to tackle the sequencing of SARS-CoV-2. It's basically consortium of NHS, which is UK's public health service, public health agencies, universities, Sanger, which is big UK institute, and it's and Lighthouse laboratories that do pillar sequencing. So I'm involved in both. So setting up infrastructure on CLIME, CLIME was basically natural fit to set it up. So COG does 3 things. It like produce data, so those are local laboratories or local sequencing sites or big national sequencing sites, collect data. This is where the CLIME steps in. Everything is uploaded to CLIME, and integrated data, which is we feed our data to public health agencies. So we set up something called CLIME COVID, which is dedicated part of the CLIME cluster just to deal with the COG data. We have designated login node. This is the main point of entry of anyone in COG. This is how you upload the data, upload your sequences. This is how you access data uploaded by other sites. This is where you have this is where you can access outputs from various pipelines we have. We also have additional compute, we say on demand, if you need to run more compute intensive analysis. We also hook up to a Slurm cluster provided by the University of Birmingham. So you can access to hundreds of cores if the VMs we provide are not enough. We use Ceph as a main storage backend, which I'll talk about Ceph later. And our main pipeline, it's called Elan, which I'll talk about that it as well. And we have Majora, which is metadata database. It is brain of the cog. That's where all the information is stored. So login node, it's using LDAP authentication. It's shared resources for all people who, for all Cog UK users. Means everyone's on the same system, access the same data. Backend. This was probably the trickiest part to set up, as in not in Slurm, because Slurm is well known and popular. But we find out most of the stuff we are actually trying to do, or what researchers are used to, especially in bioinformatics, doesn't really work well with Slurm. So from simple issues like this, this particular software doesn't really scale well on Slurm cluster, to issues like Slurm configuration. Most Slurm instances in the world, they configured for high performance computing. Means they care about the pure performance, but not the throughput. Let me explain the difference. Typical HPC job, researchers submitted and it runs for 5 days, 10 days. So if it takes 5 minutes longer to start, given it takes 5 days to run, it doesn't really make any difference. But the way we set up our pipelines, main pipeline, ELAN, submits about, on a good day, 50,000 jobs to a Slurm cluster. So imagine, even if there was like 5-second overhead for each job, that quickly adds up. So this was the step that took us longest to actually get it right. Plus, Slurm is not intuitive to use for someone who never actually used it. So we had to put really easy to read docs and stuff. ELAN, that's our main pipeline. It is written in Nextflow by famous Sam Nichols. The biggest part of the pipeline is the QC. So we run QC on every sample that's been uploaded, and publishing, which is basically making the samples available to other researchers. It runs once per day. It also, when it finishes, it triggers other pipelines we have. So we have FallowPipe, we have Asclepian, which is our pipeline that just feeds the data we just processed to public health agencies. Plus, when it finishes, it triggers uploads to ENA GSAID. And this is the most important part of the COG infrastructure. We just basically do everything we can to make sure it runs. And since March, it didn't run only 3 days. So that's, I think we're quite proud of that. And those many late nights we spent just trying to fix it for various reasons. Majora, it's our metadata database. Sequences are uploaded to a login node, while the metadata for each sample is uploaded to Majora. It has quite extensive API, that was one of the designs. We try to enforce everything via API, so everything can be automated from sample uploads to metadata uploads, and it was built from scratch in basically few days. I mean, the bare bones, the bare functionality, it was built just in few days, and obviously after that we added more functionality. Backend, I think that was the most interesting technical challenge, how to actually connect every individual part of cog into same, so it's accessible by every service or researcher we provide. So we set on Ceph. We were already using Ceph for other parts of Climb. It's been since 2014. The nice feature of Ceph, it can provide 3 different storage layers. So it provides block storage, where we actually run our VMs and compute nodes. It provides the shared file system. That means every VM, every compute node also has the same, like I say, path mounted on it. It also provides S3, which is object store. So object store is used for publishing the results of various pipelines. It's used as intermediate storage for various for outputs, and there are a few things that we would probably do better if we start from scratch. So I think object storage in our case is very underutilized. It makes things. I think the main problems we had was lack of time to properly test and design every aspect of the system. So we have to sacrifice some functionality to get it working. If we do it again, we would definitely utilize object storage at every step. It makes some things just flow naturally. And the issues we have with Slurm, we would definitely go with dedicated Slurm cluster just for our pipelines. Those are the main things I would just change if we go back again. So that was just overview. I'm happy to just stay and answer any questions you might have, any technical. Happy to have a chat about any issues you have. Thank you.
Thank you very much. And I see that we have some questions coming in already. What technology did you use for, I guess this is about Majora, that was used for the API that allowed users to upload the sequence data sets? Do you know if there's a particular API framework or something that was used for that?
So sequences are not uploaded to Majora. Part of the main pipeline is to match the files that were uploaded to login node with the metadata that's in Majora. The sequences are stored as our files on the shared file system.
Oh, okay. So those are just being SCP'd or something like that to the file system. Okay.
Yeah, yeah.
So the sequences come in by SCP or something, and then API is.
We picked SCP or SFTP because it allows the sites to automate the uploads. Basically, all you have to do is set up SSH key, run a script that will upload the current run to COG. And just we're taking care of finding which sequence matches metadata.
Which metadata?
Yeah.
Okay. So then another question is, how do you handle the computationally intensive tasks? So, I mean, assembly, QC, and especially the phylogeny must be quite computationally intensive.
Yeah.
Do you?
So
yeah. Tell
yeah. So a phylogenetic pipeline is offloaded to Slurm because it can run for 10, 12 hours. It just makes sense to put it on Slurm. We're quite lucky here in Birmingham that our Slurm cluster is very powerful. So even adding the Slurm overhead, it's still quicker to run the intensive task on the Slurm cluster. For reliability reasons, or like to make it easy to fail over, we run ELAN pipeline on dedicated nodes because we had issues in the past where we saw people submitting tens of, say, R jobs to a Slurm cluster, and ELAN had to wait. So we basically dedicated some compute hardware just for the ELAN, because as I said, ELAN must run every day. But yeah, everything is offloaded either to Slurm or a dedicated compute node for a specific pipeline.
Okay, so I've got two questions from Alayton and Dominique about metadata, and they basically are related. Do you know how the metadata standard was developed to get all of the different bits of cog working together?
Metadata discussions. That's question for Sam Nichols.
Okay, we don't have Sam with us, but yeah,
I try to stay away from metadata. That's not my thing. But there is a Majora paper. You probably can find it.
I will put the Majora preprint in the chat.
Metadata definitions.
Yeah, and the metadata was designed before the phage metadata standard, so it's not quite the same. But yeah. Then I've got a question. So in terms of lighter or an alternative for distributing jobs to Slurm, have you used Kubernetes at all on?
No, we didn't have time. We didn't have time. We didn't have working Kubernetes cluster at the time, and it would just extend the whole build time for days or weeks. There was just not enough time to add that, and turns out it wasn't really needed. I mean, not sure what would be the benefit in our setup. What the benefit would be to add Kubernetes cluster.
And I've just got one and maybe two questions if we go quick.
Sure.
I see Alan Christophers is asking, after using Climb successfully to date, would you prefer this federated version or having one big central infrastructure? Because you have this federated Climb at the moment.
Yeah, but don't forget the Climb as a project that started in 2014. It's not the same that I was just discussing. We use some of the infrastructure, but that's not the same Climb. So you can be user on Climb, but you don't have access to cog data. That is completely separate.
So this is just one group of VMs within the larger Climb.
Yeah. So basically, we carved out some of the Climb capacity to build this. This is not Climb as a project.